Well, hello there. Hi, I'm Matt Eland, and this is Making Your Code Suck Less. I have an unfortunate truth to tell you. Legacy code is real, and within that legacy code lies technical debt and a beast that I refer to as Code Cthulhu. Code Cthulhu is this monster that lives in our code bases, waiting to devour our productivity, happiness, sanity, and joy that we should find in our day-to-day jobs. No, I know this because I've been a software engineer for 25 years, and I've been a software engineering manager and even an instructor for new software engineers. And I can tell you without a doubt that technical debt is something that is pervasive throughout the industry. I would wager that most people here have encountered technical debt numerous times throughout their careers, no matter how long their tenure has been. And in fact, some of you here may even have inflicted technical debt on others. Now, that's certainly not you, it's probably somebody sitting next to you, but technical debt is a very real thing. And in fact, it's such a real thing that can impact us so much that I spent a lot of my time last year writing a book called Refactoring with C#. And this helps .NET developers really help them understand their technical debt in their code bases and pay it down in strategic ways, and helping them build better teams that can also pay down technical debt and work through things. So this is an area I have focused on in my career, especially recently. Now, I'm not the only one who's focused on this, and to define technical debt, I'm going to turn to Adam Tornhill, who's written a couple of wonderful books, actually 3 books because he's got a second edition of one. But anywho, Adam Tornhill defines technical debt as code that's more expensive to maintain than it ought to be. Expensive in terms of time, money, defects, developer happiness, productivity, joy, that kind of thing, right? Another definition that I've seen out there that I really like, I'm not sure I fully agree with, is Michael C. Feathers in his book, Working Effectively with Legacy Code. He says that technical debt is just code without tests. Now, I like that because it's punchy. I'm not sure it's fully something I agree with because I've certainly found tested code that I want to run and hide from, though the tests make it a little bit less scary. Now, I've written a book and I can't even remember how I define technical debt, and I'm too lazy to look it up, so you're going to have to do that for me. Instead, I've come up with this definition right here. Technical debt is potentially addressable risk that your current code, architecture, infrastructure, or data will negatively affect you in the future. Okay? So it's something we could do something about, but it's a risk that may affect us in the future one or more times. We're going to get back to this definition of technical debt as risk. But first, let's talk about the impact of technical debt. With technical debt, you'll find that stuff breaks when you try to change it. When you try to change a feature, when you try to implement a fix, stuff will break in other areas. Those areas might be neighboring to where you tried to fix it, or in extreme cases of spaghetti code and rampant technical debt, you may find that changing one small area of the code impacts drastic things downstream in other completely different areas that you wouldn't think would even be related at all. Now, this technical debt in our code can also make bugs harder to find. It's harder to isolate the bugs, so you're spending more of your time fixing the bugs that are there, and conversely, you're having more bugs reach production, so you're fighting more of these bugs more of your time. Right? So this is really almost the worst of both worlds, where you start having more and more bugs that you're going to have to fight, and you can't find them because of your technical debt. And when you do fix them, your odds of introducing more bugs is significantly higher than it otherwise would be because of your debt. Right? So this also results in features that you're working on taking longer to complete than they ought to because, well, your code isn't as supportive as it could be of expansion, or you need to spend your time making sure you don't break anything. And so as a result, well, you're really afraid to make any sort of a change. And that is really unfortunate because, well, when you start pushing back features and aren't able to deliver on a predictable schedule, then releases start to get delayed. And when releases start to move, well, then a lot of nastier things happen and management starts to get, well, let's say displeased, right? And when this happens enough times and you try to fix things and you fall on your face or you wind up breaking things while trying to make things better, well, at a certain point, most developers are going to start to lose hope, right? This is a very real fact. You start out just brimming with joy and trying to, like, I'm going to make this place better. I'm going to improve this code. We can't live like this. I got to fix this. And oh no, I broke production. What do I do? And after enough times and enough failed attempts, you stop volunteering to make things better. You stop believing that things can get better. You lose hope. And eventually, if it gets severe enough, you'll find yourself or others just decide, you know what? I don't want to have to deal with this technical debt anymore. I can't resolve it here safely, so I'm going to find somewhere else that doesn't have any technical debt. Spoilers, that place doesn't exist, because from the moment you create a new project, you're going to have some degree of technical debt that's only going to grow as time goes on. And also, why is it always farming? Why do developers often leave development to go farming? I know at least a number of people who have made this career change. It's very interesting. When you lose developers on your team that knew things, you lose a lot of additional knowledge, right? You lose the context of why decisions were made. You lose the context of what else was considered, how to test things, how to even find your code. I've been in that situation before where I even had to reflect code to figure out what was in production and which branch we were working off of. You should never be in that situation, and yet sometimes you're going to find yourself there when people leave or you have unexpected layoffs or other things like that, right? So that's a bad situation to be in. And if you get to bring in new devs, well, those devs are going to have, one of two reactions. Their first reaction is going to be, "You live like this, bro? Like this is fine? Okay, I'm not sure I want to sit with you at lunch anymore." Or the reaction is going to be, "Oh, this is how you do things here? Got it. Okay, boss, no problem. I'm just going to copy and paste from here to here, and you're going to see a lot more of the code you have right here. I'm on it, boss. Don't worry about it. I'll check in with you next month." Both of those are very scary reactions, but they're both realistic reactions that I've seen before. And so after time, if you don't pay down this debt, it just keeps getting higher and higher and higher until you have this system that's so degraded that you really can't do anything with it. And you're tempted to just write it off as a total loss. And more importantly, your team is feeling unempowered and without hope, and just you're not heading in good directions when these things happen. So my overall takeaway for you today is that it doesn't have to be this way. We can get to a better place, and we can do it safely and iteratively, and even in an agile way that supports the business. Okay, so let's talk about how we get here and how we avoid getting here. There's a number of different causes of technical debt, but I like to think that most technical debt comes because of natural entropy. When you build a system, it was built for a specific purpose. The purpose that it was built for may change over time as your organization's needs change. Okay? The context in which the code runs is going to change sometimes. The number of users might change drastically. The types of users might change drastically. The industry that it operates in, the operating systems it runs on, the expectations of your users, the frameworks it runs on, and even various other things. From the moment you build your application, even if it's perfect, it's going to start to decay over time because you've got security vulnerabilities, you've got updates, you've got new standards, you've got new architectures, you've got an increasing base of users and executives and product managers and all of these other forms of change. And so constant evolution is the norm in software engineering. And with this constant evolution comes this natural entropy that just wears down our products by increasing the amount of technical debt. Now, the way we fight against this is through the process of refactoring. Now, if you're not familiar with refactoring, I'm going to plagiarize from myself here. I'm going to show you let's say a 30-line-ish method in C# that has some things to be desired. I stole this from myself from Refactoring with C#. This is an early example from chapter 2, I believe. But this method does a few things. It basically calculates the price of a fictitious airline ticket based on your baggage needs, whether you're traveling on a holiday, the number of checked bags, the number of carry-on bags. And it's a little hard to fit it all in your head at once, and that's sort of the point of this screen here, is that this method is a little harder to maintain than we might want it to be. So let's look at a tiny portion of this and see how we can make it a little bit better. So this here prices our carry-on baggage. And what we're going to do is we're going to say like, hey, look, we're doing this logic here of each carry-on item costs $30 on our airline, right? If I ever need to change that price to 35 or 25 or whatever, I need to modify 2 lines. Well, that's a problem because I might forget to modify one or might not know that I need to modify more than one. And so we can extract a local variable that stores the result of this calculation and then use it in these 2 lines. And that would look like this. So with refactoring, we are changing the form of something without changing its functionality. Okay, still does the same thing. It's a 1 line of code more, but now if we need to change it, we're changing things in one place instead of two. Right? So if that works at that level, well, we can look at things at a different level. But first, I want to point out that these refactorings can often be done automatically. Our integrated development environments, or IDEs, have features such as introduce local variable, extract method, inline method, things like that, that will automatically carry out common refactoring operations in an automated way that reduces our odds of being distracted or making a mistake during the refactoring. Now, it's still our responsibility to make sure it didn't mess up. These tools actually used to mess up a lot more than they do now. Now they're pretty reliable, but you still need to take a look at it. You really need to take a look at it if you're using Copilot, because you don't know what it's going to do. Most of the time it might be right, but large language models are sort of like aiming a jar of canned lightning at something. So here's another chunk of that larger method that works with the checked bags. Okay, so here we have a case where we're checking less than or equal to the number of passengers, and a case where we're checking more. And the logic is a little bit different on how it's priced. And so with that complexity, we have a few other conditions here, but we still have the same basic calculations. And so we can introduce a local variable to store the results of the calculations of the bags at the per passenger level, the cheaper rate. Okay, so the first bag fee. So we can extract a variable and have it be calculated and used in different places. Now, this is more code, but bear with me for a second here. If we can extract the first baggage fee, well, then we can extract another variable for an additional baggage fee. And with that, we can actually now move things out of our if and else blocks and just say, like, look, we're just going to have the total checked fee be these two things added together. Our code is longer, but it's simpler. It's easier to read and understand. And if we need to modify how it's displayed, we're modifying it in one place. Again, don't repeat yourself. Again, don't repeat yourself. So that's sort of the idea and flow of refactoring. But when you look at this, you said this is a lot of code on the screen, and this is just 1/3 of that overall method. This right here could really be its own method. And so we can make it that. We can use an extract method refactoring and just say, like, hey, this code is now gone from the larger method, and it's its own method right now. And we're going to call that method and get a value, and we're going to use that value in this method. That code is still here. We have it now defined as a static method in this case, and we can use it and test it a lot easier now. And it's easier to understand on its own. And looking at it this way, we can say, hey, I've got this if bags is greater than 0, and if it's less than or equal to 0, I'm really not doing anything. I can use like my invert if refactoring. I can say, hey, if we have 0 bags or less, let's just return. There's no charge here if you're not checking any bags. Okay? So that's an example of just a inversion of nesting there to improve your code flow. Now, if extracting one method improved us significantly, extracting a couple more is going to help things even more. So we can introduce methods for the checked bag fee and the carry-on fee and the holiday travel fee. And pulling out those 2 additional methods makes our core method a lot easier to understand. We're now under 20 lines of code long, which is really where I try to be to make methods understandable and testable. And reducing things to this level shows me a couple places where I can make things even better. So first of all, I'm really just calculating a subtotal and passing that subtotal to the calculate holiday fee. And secondly, I could really call that out with a comment stating that the calculate holiday fee is based on that total. So here's our final version of this. It's very small, easy to understand, easy to maintain, and it farms out its logic to other methods that are also easy to understand and easy to maintain and easy to test. Speaking of testing, I don't know if this, what I have here, is better than this. It certainly looks better than this, but we know this one is free of bugs. Well, how do I know that my new one is also free of bugs? Well, I can test it, right? And that might mean manual testing, but in this case, this is actually a really good case for unit testing. So here I'm going to rely on my existing unit tests that were in place before I started refactoring the code, and I might add some new additional unit tests based on things that I see that we are missing. Okay, so when I run my unit tests, I'm going to say, in this case, .NET test. It's going to go ahead and run my tests, and they all pass. So I'm a nice and happy man. I'm checking in my code, and we have a better feature that's now easier to maintain in the future. It's a small scale refactoring, making a method more easy to understand and test and maintain in the future. Larger scale efforts will often involve multiple classes, and you're actually starting to refactor at the design or architectural level. These things tend to need more dedicated time to design and test and implement, but they tend to have a larger impact on your overall software system. You tend to need to plan around them as general work items, though, when you're doing something this large, because chances are you'll step on somebody else's feet with a merge conflict or similar, and you want to try to minimize that and orchestrate your testing as a team. One thing I think people neglect to do more than they ought to is actually going in and refactoring your database. So when you design your database schema, you tend to say, hey, these are my tables, these are how they relate to each other, if you're using a relational database, for example. And then your schema will evolve, but it usually evolves only by adding complexity. We rarely ever take complexity away. When we remove features, we often don't even delete the columns that those features relied on, or the tables. And so you need to actually look at how can we evolve our database to be more maintainable and testable and just better for performance and developer productivity in the future. Now, when you refactor, when you think about refactoring, there are a couple main objections to that. One of this is scheduling, which we're going to talk about in a bit. The other main objection is quality concerns. The quality concerns is like, hey, I'm not going to let you improve this because last time you tried to improve something, you broke everything horribly in production. Well, how do we stop ourselves from breaking things in production? Well, we're going to need some shields for that. We're going to need some unit tests. We're going to need some manual processes for testing. But sometimes we don't have any tests at all. Their shields are down. What do we do in these cases? Well, you're going to need to do one of a few things, and maybe it's a combination of things. The first thing you're going to do, if you don't have any tests at all, is you're probably going to have to do some manual testing. You're going to have to spend some of your valuable time testing the software, making sure it works. You should be doing this anyway as a developer, but you're going to have to do it more if you don't have any sort of a safety net to rely on. You may have some documented practices, you may need to do some exploratory testing, but it is your responsibility as a developer, if you're changing something, to guarantee that it doesn't break anything or that you've done all you can to reduce the risk of it breaking anything. That can be manual testing, that can be automated testing, it can be a mix of these things. Some changes you know are going to be very obvious if you broke it. Anybody ever seen this screen before? This is a ASP.NET error page with developer error exceptions visible. If you see this in production, it's a very, very bad sign. It's a security flaw. Don't show these level of details in production. But some of your bugs are going to be very, very blatant when they break. Right? If you have a dependency injection issue that's not configured properly, your app's not going to start in many cases. But some of your issues are going to be a lot more subtle, where you're going to get bad data into the system that hurts you months or quarters or years down the road. Right? So it's up to you to determine the subtlety of a likely bug that you might have introduced and plan your testing around that accordingly. Because it's easy to guarantee the application still starts. It's a lot harder to guarantee that the data it works with is correct, or it's correct in all cases. If you don't have any tests at all, you probably have a lot of bugs. If you have a lot of bugs, well, that's great, because you now have a great opportunity to pick one of those bugs that's the most testable and start doing test-driven development with it. What you do is you start by writing a test that fails but should pass. So for example, if users named Matt generate an error on the login screen, well, I'm writing a unit test that tries to log in as Matt, and I'm verifying I don't see an error. That test should fail, and then I'm going to go in, fix the error, run the test again, and now it should pass or turn green. And then the third thing you do is, now that you got a passing test that covers this case, well, now you refactor, you improve your test code, you improve your production code, and then you run your tests again. And if you think there's another test case that you need to add, you add it, it should turn red, and then you make it turn green, you refactor. And then you move on to the next feature once you're ready, your next fix once you're ready. Right? This is really important stuff to do, and once you do this, you're going to have a larger and larger and larger body of tests available to you to catch issues in the future. Some code is going to be harder to test than others. User interface code, for example, can be pretty hard to test. For that, there's testing frameworks like Playwright is a very popular growing one now that I tend to look at when I'm trying to do some sort of a web user interface testing. You can also do API testing frameworks and the like. We've used K6 recently with a client here at Leading Edge. That works very well for those kinds of tests. We'll talk about integration tests a little bit more. But you can also still do unit tests even if you have a lot of dependencies. And that typically will involve mocking something. So instead of having your code actually work with an external API or actually work with a file system or actually work with a database or whatever it is that you don't really want to integrate into your unit test, well, now you're mocking it. You're just going to say, hey, here's a fake database and here's how it's going to behave. Here's a fake file system. Here's how it's going to behave, right? And so you're testing your code and you're using dependency injection to give it a fake version of this. This makes your tests a lot more complex and harder to read. And so it's important, especially once you start adding mocking, to really constantly refactor your tests and extract methods, extract helper test classes, extract base classes within your testing framework, right? So that your tests can really be focused on the things that you're trying to test, and you don't have to scroll through a long test to understand what even the setup is, right? So that's really important, especially once you start adding mocking or complex setup of all your dependencies. What if nobody else is testing? Well, yeah, you're going to be a little lonely. Yeah, you might get some weird looks at stand-up when you're talking about you're spending your time on unit tests. But if all goes well, you're going to have fewer bugs than your friends. And when things do go wrong, well, you'll be able to fix them with more confidence because you have tests in that area. And when your coworkers go in to work in that area in the future, they're going to say, oh, well, I was going to check this in, but my pull request was denied automatically by the build system because it said the tests are failing. Why'd you break my tests? Like, it's your code. You broke my feature. Please don't do that. The tests will help you, right? And once you start showing your peers how to get started with testing and the benefits of that, and especially how to test hard to test things, they're going to say, oh, okay, well, can you help me with this? All right, what do you think of this test? Well, I think this test could be better. And pretty soon it's not going to be one of you. You'll have the rule of two, and then you'll have a whole Sith army of testers going out to conquer the galaxy, and that'll be great. There's still going to be a percentage of time when you're going to go out there and you're going to actively break something when you didn't mean to. There's going to be a test case you forgot to add. There's going to be a way of manually testing it you didn't consider. There's going to be user data that you didn't even think of, right? That's, I hate to use the word okay, but that's somewhat normal, okay? You want to try to minimize the percentage of times that a bug is going to reach production. And if you find that a bug reaches production, you got to look at it and say, how did this get out there? What can I do to prevent this from going forward beyond adding in extra meetings, right? Usually extra meetings is not a good long-term solution because, yeah, then all your time isn't just in meetings. Nobody here has ever been in that situation before, I'm sure. But you want to look at what kind of tests can I add? What kind of automation can I add that might help catch some of these issues? I watched a person once write a whole lot of unit tests and ship a feature, and they completely broke a dependency injection. The application wouldn't even run. And they're like, well, Matt, all the tests are passing. Well, the application's on fire when you try to run it. You can solve this with an integration test. Integration tests are testing how different parts of your system integrate together. So here in this lovely little GIF or GIF, depending on your religion, we have a working door, we have a working lock. These two things both work in isolation. When you integrate them together, they are rather pointless. I like this one even more. We have two automatic doors or gates. They are working just fine. They are motion triggered, and well, there is motion, so they are triggered. So component tests are great, unit tests are great, but you are going to need some level of integration tests to make sure that everything works fine with your dependencies. You're going to need to find a framework that works well for you, depending on your technologies that you are working with, depending on all these things you care about, and how much it takes to stand up your resources. Okay? But these are really important to have at least a few of these things just to find blatant smoke that pours out of your system in some places where your application can't even talk to the database, for example. All right, so we talked about quality concerns. Let's shift gears a little bit and talk a little bit more about scheduling concerns. Anybody here work in Agile and ever bump into the end of sprint crunch, where you get a pull request from somebody and they're like, well, you really should have implemented this feature this other way, but if we go back and rework that, well, it's not going to complete the sprint. It's going to have to push the next one. As a result, you either have, a significantly lowered velocity, or you have a habit in the waiting of cutting corners near the end of a sprint and compromising your standards. Well, you ship something and you show somebody that you can ship something in that amount of time, and you've built up that technical debt, and you're probably not going to get to pay it down next sprint. And once you do that every 2 weeks, well, you now have an automated way or an accepted, established way of getting technical debt into your system. The solution to this is actually to release more often. By removing the pressure of saying, I have to get this in for the monthly release or the end of sprint release or whatever the release window is, you remove that temptation to cut corners. If you release every 5 minutes or at the end of every day, your temptation to cut corners is a lot lower. You want releases that are frequent, automated, supported by tests, and just very small incremental changes. Because that way, you're never going to be saying, oh no, oh no, oh no, I got to get this bus out the door, or we're going to have to wait 2 weeks, or we're going to have to push our major release, or whatever it might be, right? Release more frequently, and you'll be able to release with more quality as you go. As you're going, you should follow what many call the Boy Scout principle. I don't love the gendered term, but it comes from the Boy Scout principle of, hey, when you're at a campsite, we're going to make our campsite, any campsite we stay at, it's going to be as good or better when we leave it. Okay? So when you're working on code, you want that code to be as good or better when you leave it. That might mean doing a little bit of refactoring as you're fixing a typo. It might mean doing a little bit of cleanup as you're modifying a method. You're probably not going to go in and completely re-architect an application because you're fixing an index off by one error somewhere, right? So you got to make it proportional to what you're trying to do. But this can help you improve your code quality at the kind of micro level. The nice thing about doing it this way is that the places that tend to change the most tend to get the most improvement out of this kind of a workflow. That helps you sort of naturally optimize the things that you're trying to fix. Now, some types of fixes are a lot trickier to implement as a kind of a ad hoc thing. And for these larger work items, such as maybe changing your database layer or how transactions work or upgrading a major version of an Azure library, for example, you might need a larger work item and just saying like, hey, we're going to get this into our sprint. This is what we're going to work on. We're going to do a systematic test of this, that kind of thing. And with that, there can be a natural pushback from the business side of things saying, well, wait a minute, you're doing this. What am I not getting? I need to give you 5 story points for paying down this piece of technical debt. Well, I wanted this thing that our users really want, or management expects me to get this out this month. I think this is an important discussion to have with product because it sort of implies that technical debt has no business value. Technical debt does have business value. It resolves risk that the organization faces. Additionally, when you think about paying off technical debt, I like to think about that as saying, look, right now we're spending a certain percentage of time each sprint fixing bugs. What if we had fewer bugs to fix? What if we had less sources of bugs by reducing our technical debt? Let's fix some of the holes in this boat that are getting some of the water in and spend less of our time bailing out all the water. We're going to be better off in the future as a result of this. And it's kind of an ongoing conversation you're going to have based on the needs of the business. Speaking of which, technical debt is not always bad. Please don't throw things at me. But sometimes technical debt is what you exactly need as a business. I worked at a startup where we were trying to demo our software at major trade shows to get buyers and additional funding and major deals made, and we couldn't just not show our software at a trade show. We needed to get features working, even if they were in a beta state, even if everything was kind of hacked together. So we would strategically rack up a lot of technical debt sometimes to increase our odds of succeeding as a business, and it was what kept us alive. Now, we did need to pay off those pieces of technical debt, and they did hurt us over time in forms of new bugs and slower release features. In fact, we ultimately paid more time due to those pieces of technical debt that we took on, but it was a strategic investment to keep the business alive, to meet key goals with a fixed timeline, right? So technical debt is not always bad, just like taking out a loan for your car or other things might not always be bad. One of the things I like to look at on a regular basis, and things I think about in the car while I'm walking the dog or whenever, is are we getting better or are we getting worse? Or are we staying the same? This can be from a code perspective, this can be from a product perspective, this can be from a team perspective. But this is an important thing to take a look at. And if you're not sure, or if you are pretty sure you're getting worse, well, that's a problem, right? And that's usually a problem that you can solve at a code review level. Some organizations won't even be reviewing code, where no developer has to approve code before it gets merged into your development branch. Others will maybe be having ineffective code reviews. There's almost always something that another developer can do to help you improve a feature, to educate you into something you didn't know about the system or about the languages or technologies you work with. But so often our code reviews will get hung up on stylistic things such as indentation or brace formatting or the use of var or other things like that, right? One of the biggest eye-openers I had as a early senior developer at the time was by using an automated tool to format our code in a consistent way. That simplified our code review process, even if I didn't really love all aspects of the style that it applied to our code. Because people were able to focus on what the code actually was instead of how it was styled, we were able to have healthier conversations. Now, the other thing you got to do is you got to make sure that you're sending people a reasonable amount of code. If I'm sending somebody 20 lines of code, well, they're probably going to give me some good pieces of feedback about it. If I'm sending somebody 200 changed files and 50,000 lines changed, they're probably going to say, let's Google that meet, or LGTM. Looks good to me. The right answer to that is if I or somebody else on my team does that, is like, okay, time out, party foul, we need to have a meeting, talk to me about these changes, talk to me about why these changes are all together, talk to me about the risks of these changes. And you start to have this discussion as a team and understand where the developer is coming from and the alternatives considered. And you may decide, okay, well, yeah, let's actually go through and review this. Let's divide this up. Bob, you take this. Priya, you take that. I'll take this. And we'll reconvene in a day and just talk through a little bit more. But with those larger things, you often will need a formal code review meeting, just because otherwise you're just I'm going to lose focus after scrolling a certain amount of distance. It's just human nature there, right? But code review is a really great way of sharing knowledge of your code base, sharing knowledge of tricks and tips and things to avoid. And it really should be done within your organization as a vital part of what you do. Now, it shouldn't be unassisted, though. I think that we should have tools to help us in our code review process. At the bare minimum, we should make sure that the unit test suite works, preferably the automated tests with integration tests also work. If you've got Terraform or other pipelines like that, make sure that they still run and build and succeed. Right? That's all important stuff on any pull request before it's merged in successfully. Right? I think you should also maybe include tools like SonarQube or SonarCloud that do code analysis of code as you're attempting to merge it in. So that while developers are looking at your code, they're going to see things like the cyclomatic complexity metrics, any warnings associated with it, the duplication percentage, maybe even the code coverage percentage. God forbid people care about that. But you'll have these little things to help you as you're performing your code review. And you can even look at those before you share your code for code review with other people, which is really handy with draft pull requests. There are some things that you can do with a team to make your team better. I still maintain that Jar Jar was a Sith Lord and was behind it all. He's probably how Palpatine returned. Should Palpatine return? I don't recognize officially any movie after Return of the Jedi, just saying. But there are some things you can do to make your team better. Now, first of all, you got to make sure your team is able to identify bad practices and bad patterns. If you have your new developers saying, oh, this is the way, this code here that you have that's riddled with all this technical debt, that's what I should be copying from, cool. Well, they're going to copy from it, right? And you got to tell them, like, let's not do that, right? That's not good. Or these are our standards, we really should be doing this. Usually there's linting or other things like that to help you catch those types of things at a language level. .NET has things like Roslyn analyzers that will help you flag common issues in your code. You got to make sure your team's knowledge is up to date. Lunch and Learns, encouraging people to go to local meetups. Shameless plug, I help run the Central Ohio .NET developer group. We meet the fourth Thursday of every month in Columbus, so check us out. But conferences like this, online videos, online articles, however you'd like to learn. You just need to keep learning. You need to keep your team learning, even if they don't always want to be. Find ways of incorporating it into your day-to-day processes, because it's important to have an effective team, not just now, but in the future. You got to make sure that your developers aren't following through with that copy and paste driven development. Because if they're copying and pasting something, well, that's bad even if the code they're copying and pasting was good, because now it exists in two places in slightly different forms. But if it was bad, that's even worse. So I think you should give every new developer who joins your team a sort of verbal map of the organization saying, look, there be dragons over here. We're not proud of this code. It's not actively hurting us as much as you might think. So really focused over here, but we don't consider this to be good code. Our current practices are best really established in this area over here because it's kind of newer features. So take a look at this. This is really what we're going after. We really hate this. I'm so sorry about that. We're not going to touch this over here. This is going away soon, that kind of thing. Tell people where everything is in your application. Okay. Now, there's something maybe even worse than copy-paste driven development, and that is large language model driven development, or LLM driven development, ChatGPT driven development. Oh my goodness, so many terms that are even hard to pronounce here. If you are finding your developers, particularly your junior developers or your seniors who are changing technology stacks, are giving you weird code, they can explain it to you in stand-up or in code review or something like that. If you suspect something's going on, you're stuck with this code, right? And if they think it's the best, taking anything from a large language model is sometimes like copying from Stack Overflow's questions rather than its answers, or even sometimes the answers. But it's your responsibility as senior technical leaders to communicate those standards and expectations to other people. Documentation is really important, and especially documenting your decisions as to why things are the way they are, or what other alternatives you considered, or why this has to happen before this. I can read a for loop. I can read a switch expression. I can read a class inheritance hierarchy. I can read many things related to code. I cannot read your mind as to why you designed it this way instead of a different way. Tell me that. Tell me the things I need to care about. And really, you're going to be telling your future self that as well, because you can't fit all of this stuff in your head at once. So now that we have code that we think is good, let's talk about deployment, because deployment, often we think it's going to go hyperspeed, and yeah, it gets a little interrupted or just catastrophically explodes. Let's talk about some ways of averting that a little bit. So first of all, we have the idea of a feature flag. A feature flag is saying like, hey, we're going to separate the idea of deploying code and releasing code. So I'm going to deploy my feature to production, but it's not going to be active until next month. And I'm going to start making sure that the application still works fine in its current state. And then I might say like, okay, a certain percentage of our users, or our beta users, or alpha users, they get to use this new version, voluntarily or otherwise. And then after a certain date, okay, well, this is going to be active, or this is now active for everybody. Okay? Feature flags can help you mitigate risk a little bit by letting you just giving an early peek to a certain percentage of users, making sure things are stable before you open the floodgates to everybody. Now, feature flags do add extra complexity at the configuration level, and in particular, they add extra complexity at the testing level because you need to test feature flags in tandem with other feature flags that might interact, and you need to test activating and deactivating these feature flags. So they don't exist without a cost, but they can be helpful for certain things. BlueGreen Deployment. BlueGreen Deployment is basically where you have two environments, blue and green. The naming really doesn't matter. There's no huge distinction between blue and green other than one is currently active and one is currently waiting in the wings. When you're doing a new release, all your users on one of your environments, and you spin up the new environment and you start slowly draining users so you have more users working on the next environment. And you're watching it for errors, and as it keeps going well, you're draining more and more users until you take the other one offline and you no longer have anybody on the old environment until you're doing your next release and you repeat. And the benefit of this is if you get halfway through and like, oh snap, there's a major bug. Okay, abort, 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 put everybody back on the older environment. We're going to take down the new environment. We're going to fix it and we're going to try again. And you've maybe inconvenienced a subset of your users instead of everybody. Another library I've found useful in very specific situations is something called Scientist, which is developed by GitHub, not on GitHub, but actually by GitHub. Scientist is a way of saying, hey, we're going to deploy the old legacy version of something and the new version of something that's kind of an experiment. And we're going to let people keep interacting with the old one, but we're going to also send the data to the new one too. And then we're going to compare notes and see what values were produced by those two implementations. So for example, our baggage pricing thing, we might have an old version and our new version if we viewed it as high risk. And what this does is it lets people continue to use the legacy version they're used to, and it lets you detect cases where the new version might behave a little differently than you had expected, right? And it could be that it's getting things right that the legacy version didn't, or it could be that it has exception cases that you didn't find during testing. This is really helpful when you can't adequately test something without production level data, and it's hard to do that in development environments. Okay? So Scientist isn't for everybody, but I found it's very, very helpful in certain scenarios. Let's talk about the elephant in the room, and that would be rewrites. A lot of times teams will put all their hopes in their software just suddenly getting killed in the night and rewritten and replaced with something beautiful and pristine and without error. Now there's a number of flaws with this plan. The biggest flaw there is that rewrites tend to fail because they're simply too big to succeed. When you're working on a rewrite project, you still have the other project up and running. And that project has bug fixes and often new features and maintenance needs and the like. And as you're maintaining it, you have to maintain the new environment. And that new environment, well, you're trying to get that up to parity with things that have been living there for years and years and years. And so software projects are hard to estimate. They are hard to plan. They are hard to manage. And as a result, it's hard to meet expectations. And your organization is going to have shifting priorities over time, and you're going to tend to want your best people on your rewrite project, but then you're going to tend to pull them away onto this other project when your urgent come up. And so rewrite projects tend to live longer than you would like them to. They tend to be abandoned. They tend to just ultimately not succeed or not meet your expectations. Even if they do, you might have too much schedule pressure to the point where your rewrite has legacy code of its own, and it has technical debt that you were trying to avoid. And so for this reason, this rewrite idea can work, but past a certain scale, it's very unlikely to. Okay? Now, I have seen 2 rewrites succeed in my career. I'm proud of both of them, but they are a minority compared to the projects that fail or linger or just get abandoned in a Git branch somewhere. So what's the alternative to this? If we can't rewrite our applications, are we just doomed? Well, no, and here's my favorite slide of the whole presentation. We're going to chop off pieces of our application. So just like Darth Vader here is chopping off Luke Skywalker's hand, just, out of act of kindness, I suppose, we are going to also chop off slices of our application. So you might have a large application that does a lot of things. We're going to take pieces of that application, such as here we might take the book flight functionality from an application and chop it off and put it into its own new application. Okay? So we're slicing off a piece of the old version. It's now in the new version. And what you can do is you can put it in front of this like an API management or reverse proxy layer that says, hey, when you get a request to look at this web page or call this API, I want you to send this to the new system. The legacy system is still in place. It lacks this functionality now, but it's going to serve the majority of our needs. And what you do is you chop off a piece at a time. So right now you've hit the book of flight functionality, but next month you might go in and implement check flight status. And over time, you're going to slice off more and more of your application and replace it with a new application until the point where your new application is larger than your legacy application. And you can do that with reverse proxies and API management layers. In fact, this pattern has been called, I believe by Robert Martin, it's been called the Strangler Fig pattern, named after the banyan tree or Strangler Fig. This is a tree that lives out there, but a strangler fig wraps up it and slowly wraps over the branches, and it strangles the original tree, and the tree dies. But its structural stability has been preserved by these vines that stretch from the forest floor up to the canopy. And so really we've replaced the old tree with these vines, and they're very beautiful for something so gruesome, but this actually really does apply well to software engineering. Now, you may look at that slide I showed you a minute ago with the slices and think, well, wait a minute, why do we have these things in one new system? Why can't we just have several? Why can't we be refactoring to microservices, basically? Well, you can do that. Microservices solve some problems that teams will face. For example, in large organizations, you can find microservices are a good solution for teams for managing work together. However, microservices do add a lot of complexity. They let you scale things independently of each other, but you now need to worry about things being offline. You now need to worry about who knows about what, and who do I ask about this? And different teams are going to make different assumptions, and it gets harder and harder and harder to coordinate with these things. These can be really helpful in these variable scaling scenarios or just large circumstances, but there is a price that you pay in communication and organization and coordination and troubleshooting and all of these things with microservice-based solutions. And so I've heard more and more people talking about maybe a Goldilocks kind of zone where you have this modular monolith approach where you have a monolithic application, but you have large modules that are individual teams sort of isolated from each other with some cross-cutting concerns and messaging layers and things like that. The key thing I want you to remember here is that it's important to refactor at the big and small levels. So as you're going around, you need to be refactoring code. You're going to need to have dedicated work items for larger efforts. And then when the time is right, you're going to need to start being able to chop off vertical slices of your old application and replace them with new. So let's talk about how we do this in an organizational setting before we close here. So you want to be able to get buy-in from other people. If you're talking to an engineering manager, you need to propose your solution. You need to say, hey, this is the problem, this is how it's affecting us. I think this is one of our most important pressing architectural problems. This is what I think the solution ought to be. This is what I think it's going to take from a scheduling perspective. And your engineering manager is caring about, okay, is this right? Is this what we really ought to be caring about? Is the solution going to work? Does the solution have any trade-offs that we need to be aware of? That kind of thing. We're having a technical discussion about that. If you're talking to somebody in product, or you're talking about an engineering manager who's going to have to talk to some business leaders about things, well, now you're talking about what don't we get? How does this pair with our plans? Is this really hurting us the way that you say it is? What are our odds of breaking this? What are our odds of succeeding on time? Who do you need? What's going to work, right? So when you're communicating to these folks, you need to be specific about what's hurting you. You need to be specific about who's going to solve it, how you're going to solve it, and when you're going to solve it, or how long it's going to take you to solve it. You need to be specific about the risks that you're aware of as well. Be honest with folks. You're giving people information about a problem and your perceived solution to said problem. Okay? Now, you're going to want to bring some data to support your claims, so you can say, hey, this is an issue. We've had a lot of exceptions in this area, or this has hurt these specific work items. This has led to Bob leaving the organization because he was just fed up. That kind of thing. Whatever supports your argument is important to bring to the table to help them understand your point of view. And in particular, personal anecdotes of how it impacts people, whether they're people in your organization or your end users, I think are going to be really helpful as well. Remember, your goal is not to win an argument. Your goal is not to completely eradicate technical debt. You're always going to have some degree of technical debt. Your goal is to try to manage it, and more importantly, to manage it together with the business. You want to have this partnership to rule the galaxy, business and product and engineering all together. If you're still finding too much resistance there, you might need to move things from a technical discussion to a discussion again about risk. Because product, they don't care about caching necessarily. What they care about is risk. You're saying, hey, we have a current risk that we're going to have a security breach. We have a current risk that performance is going to get too poor for people to be able to enjoy the system. We have a current risk that features are going to get delayed, that new bugs are going to be introduced in a public-facing way. These are risks that we have. And once you start orienting the conversation about risks and risk areas, and you might even track these in like a spreadsheet we call a risk register, or as JIRA work items, you can have a regular meeting with folks and say, like, look, This is where that's hurt us last quarter. This is how much time we think we lost due to this particular bug. And once people understand, oh, this is where this is actively hurting me, now that's where you start getting people saying like, hey, can we add that to our sprint? Can we work on this in this sprint, right? So that's really helpful, really good. Okay. Now, where do you start? Because most organizations have a lot of technical debt. So where we start is typically, I like to start where things are hurting me the most, where I have a lot of bug fix commits in terms of percentage of commits. That's where I will often start to work. This is a visualization taken from a tool called Gitstractor that I'm working on for my master's degree that helps analyze code repositories for these types of issues using machine learning and just code analysis metrics. You also, so looking at where things hurt is one area where your major bugs have been. But I think another very valuable thing is talking to people on your team and saying, what areas of your code are you afraid of? What keeps you up at night? What do you have nightmares about? Because I've had many nightmares about code over my career. And so that's a valid approach as well, because your wisdom is important as a developer. Now, you also think about, hey, what changes most frequently? Well, let's look there. Let's make sure that we're addressing areas that are more likely to change, because we don't want to introduce bugs in those areas when we change them. You can also think about, where are we about to change? So our plans for the next quarter or next year, what areas are we going to be renovating or expanding? Okay, well, let's make sure they have a good, solid technical foundation. And then finally, you can take a look at how it's impacting individual people on your team. People on your teams work in different areas of your software, just almost naturally due to specializations and work items that they tend to get and just experience in those areas. And different areas are going to have different levels of technical debt. So it stands to reason that some people are going to see more deeper, darker things than other people. If you can make their lives better, well, that's probably something to look at, to help their performance, to help retain them, all these things, right? And then finally, your code analysis metrics, they will really help you out a lot. You can look at things like your density of warnings and errors. You can look at things like the duplication percentage and lines of code. One metric I like to look at a lot is cyclomatic complexity, which is just, hey, what are the unique paths through this method? What are the unique paths through my code? Because things that have a high cyclomatic complexity, they have a larger number of paths through the various methods and pieces of code. And so that's a good area to look at. Code duplication percentages, that's important, because you don't want duplicated code, because it's harder to maintain, and it muddies everything up and it tends to multiply. And then finally just your density of warnings. If you're using a tool like SonarQube, SonarCloud, if you're using a linting kind of a capability with your language, that can tell you what areas have the most issues or potential issues, and the severity of those issues in those areas. So this is a really important thing to keep in mind as you're doing your development and looking at things. So we're about at time here, so let's talk about my key takeaways for you. First of all, before you can do anything else, you're going to need some defenses. You need a safety net so you can improve your software. If you don't have anything to tell you if your software is working perfectly or not, well, that's what you need to start on now, through test-driven development, through strategic unit and integration tests, through documentation even, right? There are things you can do to reduce your risk of breaking things in the future, whether or not you're refactoring or not, right? Now, the next thing you need to do is you need to start saying, where are we hurting the most? What's important to us? Where should we start prioritizing our efforts? And then, well, start fixing things. When you refactor things, you're going to want to use a mix of approaches, such as just refactoring the things that you're working on at a little level, maybe some strategic items for larger pieces of technical debt. And when things get very extreme, you're getting out the lightsaber and you're chopping off hands. And you're saying, hey, this is no longer part of this application. This is part of another application now. But again, your goal is maintainable software that benefits the business. Technical debt is risk, and refactoring reduces that risk and therefore has value to the business. Your goal is a healthy relationship with the business that can build the right features, maintain those features over time, deliver quality to your users and to your developers. And the biggest thing I want you to have is hope, right? I want you to have a new hope when you're looking at your software systems and saying like, look, we can conquer this together. We can dominate the galaxy. We can build the right software. We can do whatever we need to pay down the right pieces of technical debt and manage our software in a strategic way to continue delivering value to our users, to our business stakeholders, and to our developers. There's a ton more we could talk about today. I've tried to give you a broad surface of all the things that I've been caring about and learning about over the years. Some reading recommendations. Strongly recommend Michael C. Feather's book on working effectively with legacy code. He talks a lot about seams between systems to read. Adam Tornhill has a pair of books. There's Software Design X-Rays here, and there's also Your Code as a Crime Scene. I actually have the first edition of that book. He recently released a second edition, but I have the first edition here for anyone who would like to take it home to read. And I also have a copy of my own book, Refactoring with C#, for those of you with a .NET mindset who are either on or managing .NET teams dealing with technical debt. And then finally, I really do strongly recommend Steve Smith's content. When I think about technical debt, our software architecture, I think about Steve Smith for making things better, which is why I had him write the foreword for that book. I thought of nobody else, and I was elated when he agreed to do it. But Steve's got some great courses on software architecture, on modular monoliths and the like, and he's speaking at this conference next hour. So check these things out. Reach out to me with questions. I'll be here in the hallway, etc. We have a couple minutes for questions, and I'd love to chat with you, catch up. Twitter, LinkedIn, email, whatever works for you. But enjoy your conference. Enjoy the things that are going on in your life, and I just hope software brings you joy and productivity in the future. Thank you.